Okay, we're in section 14, and the hope is that you followed along in the lecture and the examples that were done for you in class. So again, sequences and series. After you complete the homework in this section, though, go back to the WebAssign and do that Math 120 Topic 14 assignment in WebAssign. Again, we covered sequences. We covered infinite and finite sequences. We talked about how to index them, typically starting with 1 and moving forward to n. We talked about explicitly stated ones, recursively stated sequences. We talked about what a series is, and that's going to be the addition of the terms in a sequence. We've gone through some examples with that. Again, they're going to be very doable. You might want to do it the old-fashioned way, which is not a bad way of doing it. Certainly, reason is also another way of doing a sum. And certainly when they get more difficult, for example, this one over here that we did in class over here, it's an infinite sum, and it's a difficult one. But again, it's sort of like a grade school problem. You may not realize that until someone shows you that. But that sum, although it's infinite, was very easy to write down what it is. It's 1/3. So we want to do some examples in class. Again, typically there's a footnote in these problems over here. Typically that footnote will tell you where we're starting, like whether we're going to start at 1, counting at 1, or 0, or 2. You can count this from any integer you want. Typically, though, most people start counting from the number 1. All right, but again, you could be told otherwise. All right, sometimes they do tell you to start, like for example, in this one over here, they told you to start at counting from 0 forward. Be aware of that, and be aware there's footnotes in some of these problems over here. So we went through a bunch of examples. I'm hoping they were clear. I'm hoping that you study that material, and eventually after studying that material, the hope is that you're ready to try it on your own. All right, now this is where a lot of students say, oh, I don't really need to try because I'm really good at this. And you're not good at this until you try and find out you're good at this. But the more practice you put in, I guarantee it, the better you're going to get at this material. It really is that simple. So then there's supplemental activities. I want to point that is you should be looking beyond what's presented to you at Essex County College. You should be looking at books. You should be looking at the web. You should be looking at what your friends are doing, whether you're going to Essex County College or another school. Look at what other people are doing. All right, supplemental activities. You want to supplement your education. And granted, maybe it's not mathematics, but you really want to start thinking about becoming educated, and that's really a lifelong effort. It's a lot of activities to get there. Then there's homework. Again, the key here is you got to start doing material. You have to start trying. Right, as hard as that sounds, you got to start trying. So what I'm going to do is I'm going to go to the whiteboard, and as I go to the whiteboard, my encouragement to you is. I got to find my iPad now, and I know it's somewhere. Give me 1 second. I found it, and I'm going to go to the whiteboard. I'm going to do some Sage today as well, but let's take a look. New share. I'm going to do an iPad. Give me 1 second here. I'll pick up my iPad. And I'm going to get a whiteboard working. And give me 1 second. And again, you should have done this already. All right. Now, certainly I do recommend you still watch someone do it that partially knows what they're doing. A lot of people look at problems and say, oh, yeah, I can do that, but never try. And you'd be surprised looking at things that they might look easy. They're not easy, though. All right. Let me just get a board going here. All right. So, again, I want to point out where we are. And you should have the notes in front of you, including your work. All right. Just checking along what we've done. Again, if you feel comfortable with this, you don't have to watch me do it, but we're in section 14. And it's the homework section. Again, I want to claim what homework is something you do outside the classroom, and the activity at the classroom is really going to be learning material. Where they say write the first 5 terms of the sequence down. I notice a footnote 86 over there. And again, my encouragement to you is read the footnote. Would say assume n begins with 1. So if they want the first 5 terms down, they want A1 down, they want A2 down, they want A3 down, they want A4 down, and they want A5 down. And the question is, what's A? Well, they give me AN, which means that A is a function of n. And what is that function? Well, it's 3 times minus 2 to the nth power. Well, if n is equal to 1, All right, that's going to be A1. That's going to be 3 times minus 2, which is minus 6. All right, I'm going to put a box in this indicating I believe that's done. We'll check with the answer key later. What's A2 going to be? Well, now n is 2. Again, I can't emphasize enough times to you. N is 2. This becomes 4, and 4 times 3 is 12. And put a box in that. We'll check it later. What's A3? Well, now it's, n is 3, so minus 2 cubed is minus 8, and 3 times minus 8 is minus 24. Now, what do I notice about this thing? I really don't think I need to look at that formula anymore. What's happening is I'm going up by a factor of minus 2 each time. So if you did that, what would you get next? Well, minus 24 times minus 2 is 48. Again, I'm going up by a factor of minus 2 each time. We'll check these later. Yeah, minus 2 times 48 is minus 96. All right, let me get my red pen out. I'm going to look at the answer key. The answer key is brought to you in blue. And it says minus 6, it says 12, minus 24, 48, and minus 96. Seems like a relatively simple question. Do people make mistakes in that? Of course they do. When you practice, though, you can make less and less mistakes over time. I'm going to go to number 2. Again, we're in section 14 of the notes, and we're doing the homework. Again, it's another footnote. It's footnote 87 now, and 87 says you're going to start counting at 0 now. So they want me to write the first 5 terms down starting at 0. So that's going to be A0, A1, A2, A3, and A4. There are 5 terms there. Now, what's the formula? It's not a bad formula. At AN, it's a function of n. And what is it? It's n over 2n minus 1. Well, the way I like to do these problems, it might be different than you. I just like to put the n down, and that's on top. It's going to be 0, 1, 2, 3, and 4. I want to point out what I did. All I did was the top. Now I'm going to go to the bottom, and the bottom's really not bad to do. What is it going to be? Twice the n minus 1. I'm going to do each one separately. So 2 times 0 is 0, and 0 minus 1 is minus 1. 2 times 1 is 2, and 2 minus 1 is 1. We'll check these in the key later. Now I'm at the 2, so 2 times 2 is 4. 4 minus 1 is 3. All right, what's the next one? It's 3. So what's 2 times 3 is 6. 6 minus 1 is 5. 4, 2 times 4 is 8. 8 minus 1 is 7. All right, so I'm going to simplify them if I can. This, of course, is 0. This, of course, is 1. This is just 2/3, right? Can't do much with that. This is 3/5, and this is 4/7. All right, put a box on this over here. And go look at my answer key. All right, again, if I make a mistake, I want to fess up to it. It says 0, it says 1, 2/3, 3/5, and 4/7. All right, this is problem number 2. Again, I put 14 down. It's really section 14, and I apologize for that. Let me erase this. All right, that happens to me sometimes. We're in section 14 of the notes. I did it again. Let me go backwards. It's problem number 2 in section 14 of the notes. All right, we're doing the homework. Let's go to number 3. And, I'm just reading it to you. It says, write the first 5 terms of the sequence down. And again, there's another footnote over there, and that's footnote 88. Now, what does 88 say? It says start with 1. So I can write that down now. So A1, A2, A3, A4, and A5. I'm going to write down what the term is, and it says it's a function of n. And what is it? It's minus 1 to the n minus 1 times the sine of pi n over 4. Well, I want to do one thing at a time. What I want to do. I want to do this part over here. That's all I want to do. So, I'll write it down for you. It's, minus 1 to some power each time, right? Every time, it's minus 1 to some power. Well, if I start at the beginning, which is at 1, 1 minus 1 is none, right? This would become, 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. And 5 minus 1 is 4. I'm going to put the next thing down, which may be more difficult. It's going to be sine. Whoops, sorry, didn't close that out, did I? That would be sine of pi over 4. We'll do that later. They're all going to be sine of something. What's the next one going to be? Well, it's going to be 2, right? So it's 2 pi over 4, which is pi over 2. Then we're going to do a3. That's going to be 3 pi over 4. Oh boy, 4. That's going to be pi, right? Because 4 pi over 4 is just pi. And then 5 would be 5 pi over 4. This should be really recognizable to you, all right? I'm going to, when I say recognizable or not, I don't want to make mistakes. And certainly if I make mistakes, I want to fess up to it. So minus 1 to the 0 is still 1. That's not bad. Minus 1 to the 1 is minus 1. That's not bad. Minus 1 squared is 1. That's not bad. Minus 1 cubed is going to be minus 1. And I want to point out there's a pattern to this. It's what's known as an alternating pattern. 1, minus 1, 1, minus 1, 1, yada, yada, yada. Now let's do the sine problem. Sine of pi over 4 is 1 over root 2. All right. The sine of pi over 2 is 1. And yes, you should know this from studying the prior material. The sine of 3 pi over 4 is going to be 1 over root 2. Right, I'll do the arithmetic later. The sine of pi is going to be 0. And the sine of 5 pi over 4 is minus 1 over root 2. I'm going to simplify these. This is 1 over root 2. This is minus 1. This is 1 over root 2. This is going to be 0. And this will be minus 1 over root 2. I put a box in this indicating that's my work with the answers. I'm going to look at the answer key now and see how I did. So 1 over root 2, minus 1. Again, I'm looking at the answer key. 1 over root 2, 0, minus 1 over root 2. I realize some students might be offended by this because their teachers told you in Math 100 that this is offensive. This is not offensive. You could also write that way. I think it's much easier to just simply say this is 1 over root 2. But again, your mileage may vary. You may like root 2 over 2, but it's identical to 1 over root 2. All right. I actually prefer 1 over root 2. All right, it's number 3. I'm going to go to number 4 now. And number 4 is, they give me a sequence here. All right, this is number 4. I'll write the sequence down, and I want to be clear about it. There's another footnote over here, and I'll certainly read that to you in a second, but the sequence of numbers is minus 1, 2, minus 4, 8, minus 16. And with these 3 dots here, that's an ellipsis, they're saying this is predictable. And I do believe it's predictable. If I look at this thing over here, I know it's alternating between plus and minus. Like you have minus, plus, minus, plus, minus, plus, minus, plus, forever and ever. It seems like a typical pattern. The other thing I notice about it is it looks like you're multiplying by 2 every single time. So what I want to do is read the footnote now, and that's footnote 89. And 89 says you were to start with 1. So what does that mean? It means A1 is this guy. This is A2. This is A3. This is A4. And that's A5. So I'm going to write down AN. And again, my encouragement to you is to know that this is a function of n, where n is an integer, 1, 2, 3, 4. We can always check these. The one thing I want to point out to you from the prior problem, alternating patterns will come from minus 1 to raise some power. So I'm going to try just put the 1 down now. And if I did that, minus 1 to the 1, which I want to point out what I mean by that, would give us minus 1. So I'm going to say it appears that the power is n. Right? What's the next thing going to be? Times, well, it seems like there's something to do with a 2 here, right? All right. Now, I don't want the first term, if I put n over here, that would make the first term, A1 would be minus 1 times 2. That would be minus 2. That's not right. So I'm going to try this instead. And let me see if that works. So I'm going to write A1 down for you. And it's going to be f of 1 would be minus 1 to the 1 times 2 to the 0. What does this give us? Minus 1. It certainly works for this first term. Let's try for the next term, A2. Well, what's A2? Let's take a look at that. That'll be f of 2, right? That's going to be minus 1 squared times 2. Well, 2 minus 1 is 1. What's it going to give us? 1 times 2, which is 2. It seems to be working out really nicely. Now, again, you're at the beginning stage of your careers. I would recommend you check this. What's f of 3? Minus 1 cubed, 2 squared. That would be minus 4. It's pretty reasonable. A4, that's going to be f of 4. That's minus 1 to the 4th power and 2 cubed. What do you get over there? Well, minus 1 to the 4th power is 1, and 2 cubed is 8. It works out beautifully. Let's put A5 down. Again, a counter to check. That'll be minus 1 to the 5th power. And then when you get over there, 2 to the 4th power. Minus 1 to the 5th power is a negative number, and 2 to the 4th power is 16. It seems to be working out beautifully. So I'm going to say this is a nice formula. I'll write this down for you, for AN. If you want, you can rewrite that. I don't recommend it though, but you could, and I want to go through that with you. So I could write this also as, minus 1 to the n times 2 to the n times 2 to the minus 1. What would this give us over here? Well, minus 2 to the n over 2. That also is going to work. Let me just go through that with you. If I put 1 there, what would you get? Minus 2 over 2, which is going to give you, go back to that, minus 1. If you tried 5, what do you get? Minus 2 to the 5th power. Well, that's going to be, minus 32, but minus 32 divided by 2 is minus 16. It works out. I want to point out, though, this is probably the easiest one to write down, the one that's in the box. So what I want to do is get my little red pen out, and I'm going to go back to the answer key and check it. And what's the answer key say? It says minus 1 to the n times 2 to the n minus 1. Looking good. All right, go to number 5. Again, there's another footnote over there. And I'll put 5 down for you. And what's 5 say? 5 says that AN, I'll write this down for you. I'll read the footnote in a second, is equal to AN minus 1 over 4. And then they tell me A1 is equal to 12. This was known as a recursive sequence. It's defined in terms of itself. For example, in order to know AN, you would have to know what comes before it. So what do they want me to do? They want me to write the first 5 terms down of the sequence, but now there's a footnote over there. And that footnote says start with 2. So I'm going to write that down for you. So they want to know what A2 is. They want to know what A3 is. They want to know what A4 is. They want to know what A5 is. And they want to know what A6 is. There's going to be 5 terms over there. Well, what's A2? I'll write down for you. Well, A2 is going to be related to A1. I want to put what I'm looking at. I'm looking at this over here. N minus 1. So it's 2. That would be, 2 minus 1, which is 1 over 4. And write that down for you. This would be A2 over 4. This would be A3 over 4. This would be A4 over 4. And this would be A5 over 4. Well, do I know what A1 is? I do. It's 12. So this would be 12 quarters, which is 3. All right, so A2 is actually equal to 3. Now, again, to get A3, do I know A2? Yeah, I just did it. It's 3 quarters. All right. Now, what's A4? It's A3, which is 3 quarters over 4, which is 3/16. Yes, you're expected to simplify. All right. What's A4? Well, I just did it. It's 3/16 over 4, which would give you 3. Well, 16 times 4 is going to be 64. What goes over here? Well, A5, which is 3/64 over 4. This would be 3. 64 times 4, let's see, 240 and 256. All right, put a box in this over here. I want to go through the answers. Again, if I make a mistake, I'll fess up to it. It says A2 is 3. It says A3 is 3 quarters. It says A4 is 3/16. It says A5 is 3/64. And it says A6 is 3 over 256. Worked out beautifully. All right. So let's keep moving forward. And we're going to problem number 6 now. Now, number 6 says write an expression for the apparent nth term of the sequence. Let me write this down. 1/2, comma, 2/5, comma, 3/10, comma, 4/17, comma, 526, comma, yada, 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 yada. Now, once I put this ellipse down, they're saying that you should be able to predict it. Well, I got to be honest with you. The top is super simple. 1, 2, 3, 4, 5, 6, 7, yada, yada, yada. I do want to read the footnote, though, and I'm hoping the footnote's pretty easy to read. It says begin with 1. Now, what does it mean? It means this is A1, this is A2, this is A3, this is A4, and this is A5. So I'm going to write AN down. And AN, again, is a function of N. I'm going to do one thing at a time. I'm going to do the top first. What's known as chasing one rabbit at a time. You're not going to do two things at one time. And I don't recommend ever to do two things at one time. Do one thing at a time. What's the top appear to be? Just simply N. Let me point out what I mean by that. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Here comes a problem, looking at the bottom. You might say, I don't know what it is, and it's possible you don't know what it is. But I'm looking at 2, 5, 10, 17, and 26. There's one thing I do know about that. It does appear to be growing. Right now, someone says, I don't know how it's growing. It's not growing equally. Like 2 to 5 is 3, 5 to 10 is 5, 10 to 7 is, I'm sorry, 10 to 17 is 7, 17 to 26 is going to be 9. So I'm starting to realize that it's not like going in like a consistent way, but it's getting bigger and bigger each time. But what I do notice, and I'll put a note over here, that this number squared plus 1 is 26. This number squared plus 1 is 17. This number squared plus 1 is 10. This number squared plus 1 is 5. This number squared plus 1 is 2. So I'm going to say n squared plus 1. I'll put a box in this now. All right, let's go to the answer key. Let's see what they wrote down. And what did they write down? Exactly what we thought it is. All right, that's done. Let's go to number 7. Number 7 is a sum formula. I will be talking about using Sage to do sums, but I want to move this up, and I'm going to put this down for you. This is number 7. And again, we want to get used to these symbols. This means sum from I equal 0 to 4, and the terms are going to be I over I squared plus 2. This is a series. It's finite. And how many terms are going to be? 0, 1, 2, 3, 4. There's going to be 5 terms. And they're all fractions, by the way. Let's see. Now, I'm a big believer in chasing one rabbit at a time. I'm going to chase the rabbit on top. What would I get? I is 0. Then I becomes 1. I becomes 2. I becomes 3. And I becomes 4 and stops there. Now I'm going to do the bottom. And what's the bottom going to be? Well, it's going to be I squared. Again, I'm starting at 0. So that would be 0 plus 2, which is 2. What's the next one going to be? Well, now I just did 0. I'm going to do 1. So 1 squared is 1. And 1 plus 2 is 3. Now I'm going to go to 2. 2 squared is 4. 4 plus 2 is 6. And yes, you're expected to do arithmetic. Now what I'm doing, 3 squared is 9, and 9 plus 2 is 11. 4 squared is 16. 16 plus 2 is going to be 18. I realize this is tough, but let's go through it. You get 1/3. And again, because 0 over 2 is just 0, so 1/3. And what's 2 over 6? It's still 1/3. Plus 3/11 plus 4/18. Now, someone says, I wonder what the LCD is. It has to have something to do with 11, something to do with 3, and something to do with 2. All right, I'm hoping you remembered how you get an LCD in math. I guess that would be done maybe in 086. You get factor the denominators. I'll write this down for you. Again, if you know it, don't do this. But this would be 2 times 3 times 3. 11 is just 11. And 3 is just 3. What's the LCD? It's got to have a 3 in it. It has to have a 2 in it. It has to have 11 in it. Okay? I know it's tough. And the question comes is now, how many 3s are necessary? Well, 2. And that would be 99 times 2, right? 99 times 2 would be 198. All right, I know it's tough. All right. Now, 3 times what? Well, 3 times 99. So this is 99. Did I say 99? I'm sorry. I made a mistake there. I wasn't thinking. It happens to me a lot. So what I say, 3, it would be 3 times 2, 66. 6 times 11, 66. Whoops. Plus 66. Now 11, so I got 9 times 2 is 18. So it's going to be 18 times 3. Well, it's going to be a lot of arithmetic, right? Now 18, so I get 4 times 11, right? And so I don't like doing arithmetic, and I'll be honest with you, I don't think anybody likes doing arithmetic, but it's a skill you have to be able to do. All right, 66 and 66 is going to be 120, 132. 18 times 3 is 30, and 24, 54. 4 times 11 is 44. Whoa, this is getting crazy, right? So I'm going to divide by 2 because these numbers are getting too big for me. And the bottom would be 99. The top would be what? 66 plus 27 plus 22. I can add that together, I think. We'll check it in the answer key later, though. I know it's tough. We'll talk about using Sage later. 99. Well, 66. Let's see. 66 and 22. That's going to be 88. 108. 108 and 7. 115. All right. I think I did pretty good. And again, we'll do Sage because I realize someone says, I can't do arithmetic. You got to be able to do arithmetic. And again, I make mistakes all the time. But let's just check it, see how we did. I'm going to look at the answer key, and I'm looking at it, and I feel good about that. I didn't make a mistake. Again, we'll go back, and we'll show you in Sage how to do that as well. So let's go up to number 8 now. Hoping these are relatively simple questions, particularly if you've attended lectures and you paid attention. What's this one over here? Find the sum. And by the way, we're not saying this is the easiest way to do it. We just want to make sure you become familiar with the symbols. And this is summation from 1 to 10. And what do you have here? 2i plus 1. All right. And again, there's many ways to do it. But I got to be honest with you, if I start at 1 and go to 10, it's going to be 10 terms. I'm going to start writing the terms down and, sort of like one at a time. It's a lot of writing, though, isn't it? Let's see, 1, 2, 3, 4. I got 5 more to go. I think they're going to be easy to write down. And it's sort of going to start at 1. What I got? I think I want to point out what we're doing. We're doing this over here. 2 times 1 is 2. 2 plus 1 is 3. I go to 2. 2 times 2 is 4. 4 plus 1 is 5. I'm going to go to 3. That would be 6 plus 1 is 7. You know what? These will look like they're easy to predict on. 3, 5, 7. They're going up by 2. And you should start to see patterns in these problems. Let me write that down for you. Going to go up by 2. We'll check our answer later. What's 2 up from 11? 13. And then 15. Let's see, then 17. And then 19. And then 21. Let's see if the 21 makes sense, by the way. It does, because if you're at 10, 2 times 10 is 20, and 20 plus 1 is 21. I'm going to add these together. I'm kind of slow at addition, but you might quicker than me. And I'm going to do, pairs. What I mean by that, I'm seeing these pairs here. I'm going to pair them up and add them together. All right, what do you get over there? 16, 20, 24. Let's see, what would they give you? 28, right? And what would this give you? 33. I got to add it together. And so what are you going to do over here? I'm going to point out what I'm going to do. I'm going to take this one and add it together. And you may wonder why this, because I think it's easy. And 16 and 24 is going to be 40. And 40 plus 20 is 60. I'm going to do these two now. They give me 20, 30 is 50, 58, 61. And what does that give me? 121. Now, I can't say this enough times. I make mistakes. And I think I might have made a mistake somewhere because I'm looking at my answer key. My answer key says it's 120, and I said it's 121. So someone says, oh, you're only off by 1, don't worry about it. It's a big deal. And I want to point out why it's a big deal. I want to make sure that whatever I'm putting down is correct. If it's not correct, I want to make sure it's not correct. Let me take a look at it and see if I've done the first thing, write the terms down correctly. And I'll go through this one step at a time. If that would be 3, let's see, 5, 7, 9, And let's see, only 10, 11, that's not so bad. 13, 15, 17, 19. Ooh, I see the error right now. And it's good I can see it so quickly. Because sometimes you can look at this for days and not see it. It's right over here. And I'll put this down. What's 21 and 11 is actually 32. All right. Let me get my black ink back. All right. So again, these three guys up here, I just did those 16 and 24. I said was, 40 and 40 plus 20, 60. This was fine. But this is not fine over here, the 61. And why is that? If I add these together, what would you get? 28 and 32 is going to be 60. Let me write that down for you. And what's 60 plus 60? 120. I found my error, and I feel good about that. I'm looking at the key now, and again, I'm agreeing with it. Again, I look back over my work when I make mistakes, and you should as well. Your intent is to be truthful, all right? It really should be your intent. Let me go to number 9. And the reason we give you a key is we're trying to really lead the way to what the correct answers are. And I'm not saying I can't write an incorrect key. I can, and I have in the past. People have pointed that out to me, and I make corrections. It's k equals 1, and it goes up to the number 4. And what do you have here? K minus 1, 2k minus 1. Well, I'm going to write the terms down, and each term has 2 factors in it. And how many terms are going to be? Well, they're starting with 1, and they're stopping at 4, which means there'll be 4 terms. Very simple counting number. I'm going to do one thing at a time. I'm going to put out what I'm doing. This first term over here. I'm sorry, this first factor over here. And if k is 1, 1 minus 1 would be 0. Again, let's chase one right at a time. If k is 2, this would become 1. If k is 3, this becomes 2. If k is 4, this would become 3. By the way, super easy to predict. 0, 1, 2, 3. Now I'm going to do this one over here. So if k is 1, you would get 2 minus 1, which is 1. I also believe this is easy to predict on, and it reminds me of the last problem. If k is 2, what would you get? Well, 2 times 2 is 4. 4 minus 1 is 3. Right now, if k is, let's see, 1, 2, we're on 3 now, right? That would be 6 minus 1, which is 5. Now, what do I notice about these guys over here? For the second factor, it's going up by 2. So I'm going to say, 7. Let's just check it, though. And that would be 4. Well, 2 times 4 is 8. 8 minus 1 is 7. Let's keep going. This would be 0. I'm doing the arithmetic now. This is 3. And 2 times 5 is 10. And 3 times 7 is 21. Again, not beyond making a mistake. I think I can add together. Looks like 13, 14, 34. Get my red ink out. Look at the answer key. I did a great job. All right, simple questions. We're trying to become familiar with symbols that you may not have seen before in the past. Let's go to number 10. And what's number 10? They want me to use sigma notation to write down this sum. By the way, they're not asking you to add it together. They're saying use sigma notation to write the sum down. They are not asking you to add this together. But what do I know about this thing over here? I am going to write sigma notation down. What I do notice is that every single term is a fraction. Every single term has a number 7 in it plus something on the bottom. Now I'm going to put an index down. I'm going to say it looks like I is starting at 1. All right, now what I mean by that is I'm looking at the top. 1, 2, 3. Oh, I'd say 4. I got the ellipses there again, all the way up to 15. So I'm going to say I. And where do they stop? 15. We'll check the key later. What I'm saying over here, I starts at 1. That will be 1, 2, 3, and it stops at 15. All right, let's go to the bottom. I see the 7 plus 2, 4, 6, up to 30. What is about this over here? It's twice that number. It's twice that number. It's twice that number. It's twice that number. Let me write that down for you. And I'm going to say I'm going to be done. Let me repeat this. They did not ask you to add that together. If you want to, you can, but they just didn't ask for it. They asked for zero notation. Let's look at the key. What do they have over here? I'm looking at it. I'm seeing everything that I expect to see, and I feel good about that. All right, I've got number, oh, we're done. Let's go to my other share with you. And the reason I want to do that with you, I just want to briefly talk about, what you're going to be doing for a sage work. I'm going to put this over here. And let me get the other share open for you. And just be going to share my desktop with you. Make sure I've done that. Yeah, I've done that. I think you remember me doing the reset business. Whoops, let me get that open. You've seen me do that before, right? So let's do the sums. All right, now sometimes I don't know how to write a sum down. I bet if you look through the notes, by the way, that they have some sum stuff over here. Now, granted, they have certain code over here. You're more than welcome to use that. I'm going to use different code here, though. And this is what's nice about software. There's a variety of codes you could write down, a variety of them. I'm going to put this one over here. What I notice about this first sum, number 9, I notice we're using a variable k. So I'm going to say k is variable. Oops. Okay, I'm going to write the sum down. Sum. It's going to look strange to you. And what's the sum going to be? Well, it looks like k minus 1 times, we're just trying to learn how to use software, 2 star k. Yes, I need to put the star there. I just can't put 2k down. And I'm going to say we're counting on the k's. That's our index. And it's starting at 1 and it's going to 4. This is typical what most calculators notation would look like. You hit the return button, and what does it say? It says 34. So I'm in agreement with that. That's good. All right, let's keep going backwards. I'm going to do number 8 now. And what's that going to be? Well, they're using I now. So I'm going to say I is a variable. Typically, a lot of people disagree with what I'm doing over here. They don't like to use the letter I because it's reserved the imaginary unit. However, I notice a lot of times indexes are I's or J's or K's. All right. I is also reserved for other things, but the bottom line is people really think it just should be for the unit imaginary. But here's the deal. It's going to be used all over the place, right? In context is everything. So I'm going to write this down, and what's going to be sum, and it's going to be 2 star I plus 1, comma. What am I counting on? Well, the index is I. Where is I starting? At 1. And where does it stop? It stops at 10. 120. I feel good about that. All right, let's do number 7. And again, it's, whoops. Yeah, that's I. So I can do that, right? Sum. I've already defined I, right? I divided by, now the bottom has to be put in parentheses. And what is it? I squared plus 2. And again, I'm counting the indexes on an I. It starts at 0 and it goes off to 4. All right. 115 over 99. Yeah, again, I feel good about that. And why do I feel good about that? We've done these things by hand, and certainly a machine would be okay with this. So I think that covers it out for sums. All right. Now, if you go back over the notes, and I want to point out, looking at this over here, I guess what I did was some notes over here for you that you could read through. Maybe I'll do some of that in class too, but reset, we've done this many times before. N is a variable. Oh, here's something new. Maybe we haven't seen this one before. Assume N is an integer. All right, assume it's an integer. All right, and then I write a function down, A of N, and then I write down what A10 is, and Bn, B6. I do sums over here as well, and you can look through that code. All right, I think that's about it. I'm hoping that was for the students that need help with the homework, that helped you with it. And for the students that help with the coding, I hope that helped as well. I showed an alternate way of doing things as well. All right, good luck.